glitch, so we started the stream over again. For the context here, this is my name is Mark Smith, co-founder of CleanConnect.ai, and I'm here with Floyd Baker from Antia. Hey, Floyd.
Hey Mark, how's your day? Other than a few
Good.
glitches in the platform.
Right. So we're here to talk about Digital Twin 2.0, and I think for context, you might want to start in here with Digital Twin 1.0, and then we'll go
Yeah,
to 2.0.
sure. So 1.0 is basically what we've been doing for quite a few years now. It's being able to visualize or a static visualization of a digital twin in a facility in a plant, and able to uh, visualize real-time data in that static visualization, which is a laser scan of point cloud data. And Mark, you want to talk about the 2.0 version?
Yeah. So what Clean Connect is, we have a computer vision suite, and it is designed to help automate compliance, operations, and now asset integrity management. So this suite includes gas leak detection, quantification, autonomous gate guard, hard hat recognition, general flame and smoke, combustor device monitoring, liquid leak, and many more, which I'm going to show you. So typically, we will put, you can see up here on site, we'll have like a OGI camera, optical gas instrument camera, a thermal camera, we have optical cameras, and we'll also place cameras strategically in other places, which I'll mention um, down here. And typically, one OGI camera can cover an entire site. Now, what that allows us to do is to start to identify the objects on a site. So it's not just looking at a blob of images, it actually knows what those things are and some characteristics about certain devices. We then allow the operators to set specific zones that they want to track, and it allows them to put metadata about that particular device. So when they get alerts, they're knowing that it's this site, this time, this device, this quantification of gas. In addition, our system then allows them to put zones of exclusion. So you say, hey, if emissions show up right there at the top of a stack, that's okay. But if they go above that, that's not good. We allow to set alerts for duration of leak, size of leak, and set multiple levels of alert. Okay. The way that looks on site, you can see here. Here's an actual edge device, and it's rated for being on a site. It has air conditioning, cooling to deal with. This one happens to be in Colorado, so you can get down to -20 and plus 110. So we deal with all that. But looking at our stuff together, we have the cameras that go through our intelligent edge device, and with all the computer vision models running, MQTT up to a client SCADA system. Okay. And then all the other devices can be monitored by Antia and go up there, and they can either go into SCADA or go up to the Antia platform. And as you saw, the Clean Connect dashboard, which allows you to make all those custom alert configurations, which you only have to do really once. And then now you're going to get alerts just the way you want them.
Yeah.
Another example is non-invasive tank monitoring. So one of the problems that's out there now is in Colorado and New Mexico, for example, you're not allowed to open the thief hatch. Okay. So, and it's dangerous anyway. So we have developed a model that can see through tanks, right? Or it sees the temperature difference on the outside, and it's as accurate as guided wave radar. Now, we're not sending 24/7 video of tanks for someone to stare at a screen. That would be the most boring video ever. But as you saw there, it converts all that into telemetry data, which then goes through the SCADA system. And again, we're not looking at each of these models separately. We look at them as a whole. So it really allows us to diagnose any kind of problems. In addition, as I mentioned, those cameras that up on a tower, in this particular case, we also put a thermal camera on this side of the tank battery, on the other side of the tank battery. Okay. This is an example using the same thermal cameras to do liquid leaks. So we can find dump washout, valve cracks, tanks overpressuring, pop-offs, detect high pressure pinhole leaks. Because if you can detect a leak quickly, you can fix it for thousands. If you have a fire tube failure, it could cost you $1 million. Okay. And a big environmental problem.
Yeah.
PPE detection. So we're continuing to look at that slide. As I mentioned, the high def optical camera sees 360 degrees all the time, doesn't need to rotate, has 4 sensors in it. So we can see people, we can see if they're wearing a hard hat. It also acts as virtual security. Okay.
Yep.
We have ECD monitoring. So again, we're looking at the top of an ECD. If we see any kind of smoke or anything abnormal, we can catch it and alert. We also have flame and smoke and a bunch of other things in there. So what this suite then allows you to do is autonomous LDAR, safety, operations, and those Prove Zero energy certificates. Now you may think, what do I need all those cameras on there? Can't I just use sensors, for example? I want to show you the difference. This actually data came from a customer. They had actually a PID sensor in the corner there, and you can see the difference, right? So their sensor didn't even pick up. It had a maximum of 0.6 parts per million. Our sensor went way off the chart, and it's visual, right? So I can not only see the leak, I can measure it. I can see which way the wind's blowing. I have humidity, temperature, everything all recorded there. And again, a PID sensor just kind of gives you a graph. And if it doesn't go off, you kind of don't get anything. This particular case, clients can see what happened. They can remotely diagnose it. And in most cases, they can actually remotely even fix it.
Yeah.
So let's talk about, some of the regulatory compliance. So I'm not as familiar with OSHA and your ISO there with your digital twin 1.0. Floyd, why don't you talk about that?
Yeah, for OSHA, we were designed to manage mechanical integrity data, which is OSHA 1910 119J1I, I think. So it's specific to mechanical soundness of the assets in a facility throughout their life cycle. It's designed to manage the data, manage the data that comes from inspections, tests, any kind of maintenance activities, so that one can make repairs or changes or do whatever they need to do before it comes from together. So that's the OSHA side.
So
then the EPA side's a different story. Here's
the EPA. So we were designed to handle EPA Quad A, and we just got certified in Colorado, which is the toughest regulatory platform. So now we are compliant with EPA Quad B, C, and Appendix K. Now what that means is that our system autonomously complies. So no need to send scheduled people out there to do manual LDAR. It's done automatically, right? And it meets all of the new regulations, which they're only in draft form, but we future-proofed, okay, for the next multiple years. Plus all the data that we're generating can then help you even automate like emissions inventory. And, as the rest of this chart shows, static alerts. I'm not sure how alerts come in your system.
So we have what we call IOWs, integrity operating windows. And once you've established what that upper and lower threshold is, we manage that threshold through the digital twin with the data historian or SCADA or DCS data that talks about the specific pressures, temperatures, flow rates, everything that's within an integrity operating window. And when it's breached, either upper or lower bound or breached, then it sends out alarm. If it's about to breach, it sends an alarm just to let someone know it's about to. But if it is breached, it sends an email to let someone know that it's been breached. It's also trending that data, so you can not only see that it was breached, but how long it was breached and how high or how low it was. And that's so that you can still come back and plan inspections that look for a specific type of damage mechanism that might have occurred during that breach, and be able to see how long it might have affected it, so you can understand how bad it might have affected it.
Okay. And so what we're saying with digital twin, not only do you get that information, in addition, you're getting the video feed, right? So, and it's not just video that you look at and try to figure out what it is, but it's the right kind that's all annotated. It's showing you, like, for example, if it was a leak detection, here's where the leak is, here's the equipment that's leaking, here's the quantification, and allows you that additional information to be able to remotely diagnose it and and assess and figure out how to fix that. Again, sensor alert, based on the IoT devices, and this one is the same thing, but in addition, all that AI enhanced video. Okay. And again, we're only sending you the alerts when the system is saying there is a problem. So again, we're not giving you thousands of hours of video to watch. Nobody wants to do that. It's only when there is a problem. Okay. But we're excited about it because we were doing that, but we didn't have all that metadata about the particular device and its schedule, maintenance history, and all the asset integrity stuff. So I think combining these two provides really the next generation of digital twin asset integrity management.
Yeah.
On the repair side, so EPA, this is an EPA thing. So EPA Appendix K now requires for the first time ever that you have to record a leak and you have to record the repair. But that's all manual. You'd have to do that. So people are not used to doing video management, right? That's all automatic with our system. Reporting, a lot of manual stuff you have to do today, and now it becomes more automated.
Yep.
Manual on site, AI assisted, remote managed by exception. So what's happening is we start to use video and asset integrity. We really start to dial in with what is that common problem that's happening over and over again, and allows people to then be able to control some things remotely. In fact, we've probably taken 80% for those clients that have implemented this. They're starting to see an 80% reduction in callouts. Okay. So, and the number one safety issue for oil and gas remote sites is putting somebody in a truck. Okay.
Yeah.
And if you can eliminate that safety issue, that's huge. Okay. Distance, one of the things we've been able to achieve versus manual LDAR is see much further because the camera's higher up. It's on a very industrial grade pan tilt. We automatically dial in what's the image to get the highest quality. And so, we've been able to see 95% accuracy, 2 kilograms per hour to 100 meters. Okay. And then people who want to get that certified gas, we can now do that and automate that process. Okay. And create an S&P methane performance certificate and a blockchain energy certificate. So these are just sort of the highlights of what you can do with Digital Twin 2.0. And we have an upcoming webinar, October 25th.
Mark and I are going to dive deep into this on the 25th. You guys won't want to miss that.
And the good thing about that is there's going to be time for Q&A, and can answer any of your questions. Also, we are looking for a couple early adopters, okay, who want to be the first to pilot a Digital Twin 2.0, okay, and take asset integrity management and some of this computer vision autonomous ops to the next level. Okay. And the way you do that to just do an early indication, there's no obligation, just have a conversation with us. You just send an email to info@antia.tech and so raise your hand and say, hey, I'm interested in having a conversation about what that might look like and see if you're a good candidate for that. So Floyd, any last comments there?
No, I think you covered it really well, Mark. We're really excited about this. And again, on the 25th of October, Mark and I are going to do a deep dive into this Digital Twin 2.0, and we'll be excited to see you there. If you guys have any questions, feel free to drop them in the chat, and we'll follow up on those via email. Other than that, we look forward to seeing you on the 25th.
All right. Sounds good. Hey, thanks, Floyd. Appreciate it, and appreciate the partnership.
Yes, me too. I'm excited.
All right. See you, everybody.
Everybody take care and have a great day and be safe out there.
All right.